series convergence test. So here we have this phi series, and you are asking for hints for B, D, and converging E. And let me just go over the whole thing, but I'm not going to write down all the steps. I will just point out the key points, and then you will fill in the small details. So here we go. For the first one, we have the series as n goes from 1 to infinity of 1 over square root of n cubed plus 2. So notice that if you just ignore the 2, you can write this into 1 over n to the p series, right? So that's much better. So the idea is that we know the series as n goes from 1 to infinity of 1 over square root of n cubed, much better, because that is just the same as the series as n goes from 1 to infinity of 1 over n to the third power, but this right here with the square root, you divide the third power by 2, right? So that's 3 over 2. So based on this, you can see that it's a p series. The p here is 3 over 2. Now, we will also have to keep in mind what's the condition on p to make conclusion from this. That is, if p is greater than 1, so don't just write down p is 3 over 2. Make sure you indicate that the p, the 3 over 2, is greater than 1. And this right here is going to be a convergent p series. So we know this much better. Therefore, let's try to connect this with that by doing a comparison. And you have two choices. Either you can use the direct comparison test, meaning you do the inequalities, or you can do limit comparison test. For this one, it doesn't matter which one that you do. So I will just write this down. Use limit comparison test or direct comparison test. And remember, when you do the comparison test, either one, this and that will have the same conclusion. So that's how you compare them. So keep that in mind. Now let's take a look at part B. It's actually a similar situation. Because you have the square roots, here is just plus 3, this is just plus 1. So if you just look at this and that, this is what we know much better. So we know the series as n goes from 1 to infinity. The top is 2n in the square root, or this has a square, and then square root 5n cubed. Now this is equal to the series n is equal to 1 to infinity. Square root of 2 over square root of 5, doesn't matter. Square root of n squared, n is just a positive whole number, so we just get n to the first power over n cubed in the square root is n to the 3 half power, just like what we did over there. Now reduce this a little bit. You can put a constant multiple to the front. That shouldn't matter. And then just multiply by the series as n goes from 1 to infinity. This is the first power. Just do 1 minus 3 half is negative 1 half. So that's 1 over n to the positive 1 half like this. Now, this is our p, which is 1 over 2. But this p is what? This p is less than or equal to 1. Therefore, this series here diverges. And then when you multiply that by square root of 2 over 5, again, that doesn't matter, right? It's still divergence. Right? So here's the deal. If you look at this expression, it will be slightly harder. It's actually much harder to do the direct comparison test. Remember, if you do the limit comparison test, you take the limit. If you do the direct comparison test, you will have to use inequalities. That looks like a face. But anyways, to take the limit, it's easier this way. So I will highly recommend you to use the limit comparison test for that. And then compare this with that. And remember, when you draw the conclusions, you should use the word also. Since this converges, since this diverges, if you can satisfy the condition with the limit comparison test, you can say that also diverges. Right, so that's the hint for that. Now let's look at the next one. Here, for C, series as n goes from 1 to infinity of n plus 1 to the n over n to the n plus 3 over 2. So let's use the rule of exponent to separate this right here real quick. This is equal to the series as n goes from 1 to infinity. The top stays, but the bottom write it as n to the n times n to the 3 over 2. Now this is kind of crazy. It's like, wow, so many n's. However though, if you look at this portion, imagine taking a limit. It's a nice limit. Here, that leaves us this part right here. Again, I will write this down for you. We know that if you just look at the series as n goes from 1 to infinity of 1 over n to the 3 over 2 power, this right here has the p being 3 over 2, which is greater than 1. Therefore, this right here converges that series that we know. Here, don't do the inequalities comparison, meaning don't do the direct comparison test. Instead, try to use, I'll just say use limit comparison test. All right, that's my second hint. And lastly, you will have to know that when you take the limit as n going to infinity, here's a limit that you really have to know. 1 plus some number a over n raised to the bn power. This right here gives you e to the ab power. So if you look at this portion, because when you do the limit comparison test with this and that will cancel out. So you'll just be left with this, and you will take the limit. Simplify this portion right here. Somehow put that in that form, and then use this formula to compute the limit, and let's see if you can draw a conclusion from there. Now, let's look at D. This is a dangerous question, because it looks like a p-series. We have the series as of 1 over n to the 1 plus 1 over n, right? The common mistake for this one right here is that people will just think that, okay, this is the p, which is 1 plus 1 over n. P is going from 1 to infinity, so this right here should always be greater than 1. While this statement is true, however, we cannot say this thing right here converges. This is not correct. In fact, you cannot say this is a p-series, because in order for this to be a p-series, the power here has to be a power, constant power. Just like this, it has to be 3 over 2, always. But this is not always 1, it's always 1 plus 1 over n. But when n is 2, it's 1 plus 1 over 2, right? If n is 10, it's 1 plus 1 over 10. If n is 17, it's 1 plus 1 over 17. The power changes, that's not p-series. So what do we do though? It's kind of similar to this right here. Write this as the series as n goes from 1 to infinity. Use the rule of exponents, write that as n to the first times n to the 1 over n. Now, earlier we looked at this part, that's why I told you we know this, right? Now we are going to look at this part. Again, I will write down we know the series as n goes from 1 to infinity, 1 over n. Again, it's because of this, not because of this. You can quote this as the harmonic series, which diverges, or you can also quote this as the p-series when p is equal to 1. Either way, it's okay. Which is less than or equal to 1, therefore this right here diverges. So this is what we know. Again, by the way, right here, because we're trying to use a divergent series, this series is less than this, I'll tell you that. This series is less than that. But if this series is less than the divergent series, you cannot draw a conclusion. So do not use the direct comparison test. Instead, we'll be using the limit comparison test. And then, once you do that, I'll give you a note as well. You will have to compute the limit as n going to infinity. This and that will cancel, so we have to work out 1 over n to the 1 over n. I will tell you this right here is equal to 1. you technically have to do some L'Hopital's rule, because this right here is an indeterminate form, infinity to the 0th power, so you have to do that in detail, unless your teacher told you that that's a standard answer that you can use. Like this right here, it's a standard answer that I hope your teacher allows you to just use it, but the truth is the limit as n going to infinity, this right here, the nth root of n, this right here is equal to 1. And when you put it on the bottom, that's still equal to 1. But depends. You can check out my other video for the proof of this. Alright, let's look at the last one. So for this right here, we have the series of 2n minus 1 over 2 to the n and then times n factorial. In fact, you can do some inequality business first to reduce the expression a little bit. However, I think the intended solution is usually the following. Here's the idea. If you see n in the exponent and if you also see the factorial involved, then the ratio test is a great idea. So let's go ahead and use the ratio test. And remember, the ratio test is that we will have to check the limit as n going to infinity. This thing right here is our an, and then you will have to work out an plus 1 over an, and technically you should put an absolute value around it. This right here doesn't matter at all because all the terms are positive anyways. So work that out, and then hopefully we end up with limit L. If, I'll just say the conditions are, if L is equal to 1, sorry, this right here, the series is inconclusive, meaning we cannot draw any conclusion. We will have to do more work. If L is greater than 1, then you can say the series diverges. And then if L is less than 1, then the series converges. So why don't we work this out a little bit? Right here, we will have to check the limit as n going to infinity, put an absolute value. Let's write down an plus 1 first, meaning we just put all the n's, replace that with n plus 1. So we get 2 times n plus 1, and then minus 1 over 2 to the n plus 1, and then times n plus 1, and then you factorial that. Now, when we have 1 over n, we just have to do the reciprocal. So you multiply by the reciprocal, which we will have 2 to the n times n factorial, and then over that 2n minus 1. Okay, break this down a little bit. This right here is the same as 2 to the n times 2 to the first, and break down the n plus 1 factorial. You first get inside, which is n plus 1, and then the next number is just n, and then the following one is n minus 1, and so on, so on, so on, which is just n factorial. And then for the top, this is 2n plus 2 minus 1, which is just 2n plus 1. Okay, I'll put that down later. Here, cancel, 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 cancel. Pretty nice. So we're looking at the limit as n going to infinity. The absolute value really doesn't matter because everything inside is positive. On the top here, we have 2n plus 1 over the bottom here we have 2 times n plus 1, and then another 2n minus 1. Okay? Now, to take the limit, you can multiply this out, or you can just observe the power right here is 1. The power here altogether you get 2. So you can see the limit is going to be 0. But perhaps I'll just show you one more step, just kind of do the algebra a little bit. This is the limit as n going to infinity. The top is 2n plus 1, and then the bottom is 2n plus 2 times 2n minus 1. So we get 4n squared, and then that's 2n, and then that's 4n, so that's 6n, and then minus 2. But anyways though, really just compare the powers. The limit is equal to 0. Remember how to utilize the number here. Once we compute the limit, for ratio test purpose, as long as this limit is less than 1, we can draw a conclusion. And the conclusion is that this series, well, why don't you tell me in the comment? So let me know. Oh, I will write it down. This series converges by ratio test. Right? So hopefully this right here helps. If you have any more questions, you can leave a comment down below. Let me know. That's it.